Namaste and welcome to lecture 1 of surface areas and volumes. This is a revision session. Here of the same concept we have brought different sums to make you understand it more clearly and do your revision properly. So today the sums are based on the raised level of water. Here the sum is a glass cylinder with a diameter 20 centimeters. See, in this kind of sums, whenever possible, draw a figure and understand the question first. So here I can say that a glass cylinder means, let us draw a cylinder first. It is said that the diameter of the cylinder means this, that is from here to here, that is D, which is equal to 20 centimeters, correct? So the radius will be 10 centimeters. Now, has water to a height of 9 centimeters. This cylinder is filled with water. This is the water in the cylinder and its height, that is h, which is equal to 9 centimeters. Okay. Now a metal cube of 8 centimeter edge is immersed in it completely. Meaning of this is a metal cube means cube. See, this is the cube. Okay. Now because it is of metal, it is heavy and its edge is 8 centimeters, that is this portion. Edge means that is equal to nothing but the length of the cube, which is equal to 8 centimeters. Okay. So what we have to do is, when we place this cube in the cylinder, what will happen? See, water is already present in the cylinder. Now this cube is placed in the cylinder, so what will happen? It will go at the bottom and settle down. Correct? Because it is heavy, it is going to touch the bottom. Now, this water level, because the cube is here, the portion here where the water was there before, this much part of the water is displaced by the cube. We can say that. So, because the water is displaced, the level of the water in the cylinder has increased. So, beforehand the water was over here. Now it is over here. So, this, suppose say this was H till here. Okay. So, we have to find this height. That is the increase in the level of the water. Now, understand very precisely that this much volume of the cube, it has occupied the volume of the water displaced. Means this much part of the water is displaced, which is equal to the volume of the cube. And before that, we should try to understand that because the water is in the cylinder, we can say that water will occupy the shape of the cylinder. Okay. So we can say that volume of the water displaced is equal to the volume of the cylinder. We can use the formula of volume of the cylinder for the volume of the water displaced because it occupies the shape of the cylinder. But this is equal to the volume of the cube. So the formula here we will use it as volume of the water displaced is equal to the volume of the cube. Okay. What is the volume of the cube? That is A cube. We all know. Okay, A is the unit of the length of the edge over here. So let me write pi r square h. This is the formula of the volume of the cylinder, but we are using it for volume of the water displaced. Here we have to find the height, that is the raised of the water level. And this is equal to A cube. Here A is nothing but the length of the cube. Okay. So now that is radius of the water. Again, it is the radius of the cylinder only. And that is, how much is the radius of the water given to us? 20 centimeters. No, 20 centimeters is the diameter. So radius is 10 centimeters. Let us substitute the value. So pi into 10 into 10 into h, which is equal to, A here is nothing but 8 centimeters. Correct? So I will write 8 into 8 into 8. I will not write 8 cube right now. Keep it as simple as possible. Okay? Now we need to find h. H, we'll place it here only, and taking all these three terms on the other side of the equal to sign. So it will be in the division. So pi into 10 into 10. Here I will be taking the value of pi as 3.14. So we'll write 8 into 8 into 8 upon 3.14 into 10 into 10. Now simple. There are two decimal points and here it is 100. So what we can say, 8 into 8 into 8 upon 314 into 100. To take out these two decimal points, I will put 100 over here. So this is gone, this is gone. Now we can calculate that what is 8 cube. We all know that 64 into 8 is nothing but equal to 512. Let us divide it by 314 and your answer will be 1.6 centimeters, that is h. So the height by which h is nothing but the height by which the water is raised. The simple logic here you have to take is that water displaced is equal to the water of the given, volume displaced is equal to the volume of the given object which is already placed in the cylinder. For these kind of sums, only this concept is more important. Let us do one more sum of the same concept so it will be more clear to you. That is, a cylindrical tub of radius 12 centimeters. Here radius is directly given, diameter is not given. Okay, so let us draw, a cylindrical tub. That is, let me draw a cylinder. Okay, its radius, that is this much part, that is r, which is equal to 12 centimeters, contains water to a depth of 20 centimeters. So this is the water and its height is nothing but 20 centimeters. Now here they have said that a spherical foam ball, that is a spherical ball of radius 9 centimeters is dropped into the tub. Okay, so this is the ball whose radius is 9 centimeters and it is dropped in the tub. So again the same drawing, correct? Let me draw the cylinder. Imagine that a ball is dropped in it. Because it is heavy, it is in the bottom of the cylinder. Again the same concept, that the water this much which is displaced will rise, this much part of the water which is displaced will rise. So the height of the water will increase from here to here. This height we need to find it out. Okay. So we can say that this much water which is displaced, water which is displaced by the sphere, okay, that is it will increase the level of water now. Okay. Also we know that because the water is in cylinder, it will take shape of the cylinder. Yes, so we can, for the water displaced, we can use the volume of the cylinder, formula of volume of the cylinder. But the water which is displaced means this much part, this is the sphere, in this much part, the water which is displaced, that is equal to the volume of the sphere. Okay, this displaced water is now placed by the sphere, so we can say that volume of the water displaced is equal to volume of the sphere. Here I will use volume of the cylinder. So pi r square h is equal to, what is the volume of the sphere? We all know it is 4 upon 3 pi r cube. Here this pi and this pi, we can cancel it out because it has the same value. Do not cancel the r, okay, because it has got the different values. Now first we will understand that what is the radius of the water. Let me write here, radius of the water is nothing but 12 centimeters, and radius of the ball is equal to, that is rs, that is the radius of the sphere, is equal to 9 centimeters. Okay, now substituting this value, we will get r square h is equal to 4 upon 3 r cube. Now this is the formula. Let us keep h here only, and 4 into r cube whole upon 3 into r square. This is radius of the water, this is radius of the sphere. So we will write 4 into 9 into 9 into 9 upon 3 into r, that is radius of the water, is 12 into 12. Now here 3 ones are 3 threes are, okay, and then we can say 4 ones are 4 threes are, this 3 and this 3 gone, again this is 3s are and this is 4s are. Now we cannot cut it further, so 9 threes are is 27 divided by 4, which is equal to 6.75 centimeters. So the raised height, or we can say the raised level, h is the raised level of water, which is equal to 6.75 centimeters. Okay, so the concept is the same, only both the sums, only one thing was there, that the object which were used were different. In the first sum the cube was used, second sum the sphere was used. Now the cube, we can say that the water displaced is equal to the volume of the cube. Here volume of the water displaced is equal to volume of the cube, because in the first sum the cube was used, and second sum we can say the volume of the water displaced is equal to volume of the sphere. Correct? So the concept is same, only the objects are different, and you should know the formula, which formula you have to use. So now let us do one more sum regarding the same concept. Here also we'll draw the figure first, that is a cylindrical bucket whose base has a radius of 15 centimeters. Okay, so first I will draw a cylinder. It is a bucket or a tub, whatever it is given, but I will draw a cylinder. Correct? Now the radius here is 15 centimeters. It is said that is filled with water up to the height of 20 centimeters. Again here the water is filled up to the level, that is this much. H is 20 centimeters. Now, a heavy iron spherical ball. So the same concept, a ball, a spherical ball of radius 10 centimeters. This is having a radius 10 centimeters, is dropped to submerge completely in water in the bucket. Then find the increase in the level of water. The same concept. This is the cylinder. Here the ball is placed in the cylinder. So what will happen? This much water, that is this much volume of the water, is now occupied by the volume of the sphere. So water is displaced and the height is increased, say from here to here. So the level of the water has increased, and that we need to find. The same concept. First we will keep in mind that volume of water here is nothing but equal to volume of the cylinder. Why? Because water occupies, or we can, better option is takes. Water will take the shape of the cylinder. This is the first concept. Okay. Now second is the water displaced, that is volume of the water displaced will be equal to the volume of the spherical ball, that is the sphere. Why? Because that much space the sphere is occupied now, so their volume is equal. Now we will use this formulas directly, that is pi r square h is equal to 4 upon 3 pi r cube. Correct? Pi and pi gone. Radius of water is nothing but 15 centimeters. Okay, we will use all these values of the cylinder only. H we have to find. This is nothing but the raise in the level of the water. And RS, that is radius of the sphere, here is given 10 centimeters. Let us substitute these values. So the formula is this: r square h is equal to 4 by 3 r cube. Now let us keep h here, and 4 upon 3 here rs. This is sphere, radius of the sphere, and this is radius of the water, which is a square. Now let us put the value. 4 into 10 into 10 into 10 upon 3 into 15 into 15. This is 5 2s are 5 3s are, again 5 2s are, again 5 3s are. Now we cannot cut them further, so we will multiply all the terms, that is all the digits. So we will get 4 2s are 8, 2s are 16, and 10. So it is 160 upon 27. 3 3s are 9, and into 3 is 27, which is equal to 5.92 centimeters. So the raise in the water level is 5.92 centimeters. Okay. So this kind of sums, two objects are used. One is the sphere and the other is the cube. That is 100% sure. And you should know volume of the sphere and volume of the cube, and you will be able to do the sums. So we will be there in the next lecture with more concept and more sums. So thank you very much. Here I end my lecture. Please do the sums again and again, so it will be very clear to you. And also